Okay, good afternoon, everybody. It's 4 o'clock, so we'll get started. Hope everybody had a good Thanksgiving. We are getting down to it, down toward the end of the semester, a couple of things to go. So this is one of our two planned special topics lectures. We're going to talk about CSV files in more detail. You've already had a lot of introduction to them, but we want to close that loop and cover them in detail and talk about why they're really more important than many people would think. Wednesday, we'll be talking about graphics programming in general, various graphics techniques like the things you're doing in Project 3. Next Monday is technically the last lecture. That will be a review for the final. I will get a sample final out later this week for you to work at. And the final will be Monday the 14th. I have to look up the time again. Whenever is scheduled. Whenever Monday 4 p.m. finals are supposed to be, that's when we'll do it on Monday the 14th. I'll look that up and make sure we know that ahead of time. Next week is just going to be your review. You are doing your final lab this week, Lab 12. We're going to talk about that in a minute. I want to go over what it is. It's another really one of our special topics areas that we cover. So I want to explain a little bit about it and why you're doing it. And then keep grinding on Project 3. I will talk about some things in it that you kind of give some hints based on a couple of questions and answer anybody else's questions. As of now, you have till Friday night. You will, remember, even though you're running it on your own laptop, when you are complete, you will SCP, secure copy, that file. It should end in .ipynb, IPython notebooks, which was the former name of Jupyter. But you will SCP the IPython notebook, the .ipynb file, to gl.umbc.edu, and you will submit it as Project 3, and I'll put out the exact format of the command. And then we'll grade it either on GL directly, or we'll download them to our own laptops and we'll grade them there. And you'll have the grade back hopefully fairly shortly. So I want to talk about Lab 12, I want to talk about Project 3, and of course we need to cover today's lecture, so let's get to it. Lab 12, what are you doing here? If you've had Jeff's class this morning, that's fine. You've already been introduced to this. If you've got Tommy on Wednesday, this is what he's going to talk about. The old notion is that you programmed onto your computer. You had your Windows box, or you had your Mac or your Linux box, and you programmed on it. It had a processor, it had memory, it had a hard drive, it had a network connection, it had a DVD-ROM or whatever. And you programmed on that computer. So it was a software to hardware interface. Well, that's not the way most people actually program today. That's not the way people use computers, because it's very inefficient. If you have a laptop, I don't mean to insult you, it's true for me as well. For most of us, we really don't use very much of our laptop computing power or processing power. We can really do a lot more on it. And so what you'll find is that people use virtual environments. Now, a virtual environment can be a full virtual machine. If you talk about Microsoft's vSphere or VMware, the Dell Corporation's VMware, Dell owns them now. Basically, this sets up an entire virtual machine on your computer, and you can set up multiple ones. Now, to your code, to your Python program, it looks like you're programming on a computer, all right? The Python interpreter in your Python code looks like you're directly accessing the screen. It looks like you're directly accessing the disk. It looks like you're directly accessing memory. In fact, there's another layer of software that's managing everything. And so you have virtual environments that make it look like you have 10, 15, 20 different computers on your single system. Your code still works the same way, but you get more efficiency and more use out of your computer system. Okay. That's a virtual machine. It's gone even further with containers. The idea of a container is you package up everything you need into a single unit. It doesn't have to be a full virtual machine. It doesn't have to look like a whole computer. And you can run your code in that container. When you get into computing on clouds, when you get into Google Cloud Programming or Amazon Web Services or Azure or whatever, almost always you're going to be given a virtual environment, either a whole VM or a container, and your program is just going to be running on the cloud that way. So again, what we want to do as a special topic in this Python course in Lab 12 is set you up in a virtual environment so you can see how it works and what it does. And we also, since you're actually ahead of the majors, I've had you do more of this than the majors have this semester. Lab 12 is just more practicing installing packages and modules to perform tasks. It's the same idea as what we're doing in Project 3, where in Project 3 we're downloading and installing pandas, and we're importing Plot9. You do the same kind of thing with requests in Lab 12. So that's what we're doing with it. Let me get to it real quick and see you just skip through it shortly. A lot of it was actually written by Dr. Johnson last semester, so you see his sense of humor. And it talks about PyPy. We've talked about where you can go to find these modules. I've told you that Anaconda Navigator comes with some, and I told you how to go get Plot9. In general, there is something called PyPy, PYPI, the Python Package Index, which is an internet repository for people who want to make their Python modules freely available. You can put your module out there, and anybody on the world can download for free and use your Python package. And so that's just some background about where you go to get these things. Okay. The next part of the lab talks about virtual environments, what I've just gone through. You're going to set up a virtual environment. So it looks to your computer, it looks to your program like you're running on a brand new full Linux box with nobody else. You've got the whole thing to yourself. It's really not, because UMBC couldn't really afford to provide you all your own Linux server. But you get pretty close with this virtual environment. A note, virtual environments can be really large. If you set up a bunch of them, you're going to start running out of memory on GL, so you might have to delete some stuff. Just check with it. Okay, how do you do this? You're on GL, you're in your Lab 12 folder, like you always do, and then you just type this into the bash prompt, into the shell. You type virtualenv space vn. This is just a particular Linux command to set up a virtual environment in Python, okay? And it tells you, we try to tell you what you're going to be seeing in there as input, as responses to this command. When this command is finished, now you have a virtual environment. All semester long, the command line you've been typing into in GL, the shell we mentioned earlier this semester, is called bash, which stands for Born Again Shell. It's somebody's play on words. There used to be a Bourne shell written by a programmer called Stephen Bourne. Somebody did an update to it and said, well, why not call it Born Again? Fine, it's bash. GL is just a little weird, so you have to invoke the bash shell explicitly in your virtual environment. That's fine. Then activate it. Now we're installing the request library. Okay, I told you in Project 3, by default, use Conda to install Plot9. I know a couple of people have been having problems with Conda making it work, but they have been able to do it with pip. I showed you last Wednesday how to use pip to install it directly from Jupyter. This is the same idea. Pip is one of the installers, one of the ways that you can install these modules from PyPy. Pip, PIP, stands for the package installer for Python, and this is just pip space install requests. I told you last Wednesday, if you're having trouble with Conda and you want to install Plot9 using pip, you just type pip space install space Plot9. This is exactly the same thing. It's a different library of Python code. It's called requests. Okay. And just like when you install Plot9, you see a whole bunch of code flying by, letting you know it's working. If the code doesn't fly by, it's not working, you're going to get an error message. This will show that it works, okay? Now, in your actual code in Lab 12, you are going to download the source code for the UMBC homepage, okay? And that is what this line will do. This line downloads the source code for umbc.edu onto your virtual environment. Now, what do I mean by that? This is the UMBC homepage. This is what shows up when you type http:// This is the UMBC page, the way it looks right now, or it did 20 minutes ago when I downloaded it. Now, when we say source code, there is software that is running that produces all these graphics and shows these videos and the like. If you want to see it, I'm in Chrome. This is very similar with Edge or Firefox or Safari. You could do something else. In Chrome, I simply right-click in the UMBC page, and I click this menu option right here, View Page Source. And when I say View Page Source, this is what I see. This is the HTML code that underlies the UMBC page. This is what is actually running on your computer to produce the fancy stuff that we just showed with the graphics and everything at the links in UMBC. It's a language called HTML, Hypertext Markup Language. Okay, so in Lab 12, when you say grit page equals request.get HTTP, and we say it downloads to your computer, this specifically is what's going to be downloaded to your computer. Some variation on this. This changes with some frequency, so what I'm showing you right now may not be exactly the same as yours, depending on exactly what time you download it, but it's going to be pretty close. Okay. And so when you print grit page, when you execute this statement in the Lab 12, it will print out something that kind of sort of looks like this. Okay. If it prints out something that kind of sort of looks like this, you done good. You got it right. Okay. And now just compute how many links are present on the web page. Here are some hints. If you have a link, you can look for this particular combination of letters. Less than sign, /A, greater than sign in the HTML. And you can find it by using the split command. Remember, you're just reading in, this request is reading in text from a file. It's a string. Split the string and split it on this particular value. Okay, because that will tell you how many of these there are. If you want an idea of how many you should be looking for, whether you're working or not, go back to this text page. Let's do a Command F on my Mac or Control F, and let's look for that exact pattern. And let's see how many of them we find. Okay, it looks like in this particular iteration of umbc.edu, I found 112. So we should get an answer somewhere in the vicinity. Now, again, the UMBC page changes a lot. They update it. The staff is really good. They update it a lot. That may not be the exact number. Don't be upset if you get a slightly different number than I got, right? Look at this, play around with it. But that's all we want you to do in Lab 12, okay? In Lab 12, it's a special topics lab. It's not something that's in the main line of this course. It was something that if we had run out of time, run behind, run too slow, we could throw off the raft. But we got here. So the purpose of Lab 12 is, one, to show you can actually set up a virtual environment, a virtual machine, a container, whatever, in Python on GL, and you can then have something that looks like an entire computer all your own. And in that virtual environment, you can download and install Python packages. We're doing that for Project 3. The majors are not. The majors are doing a different project. They're not doing the same thing. We're already doing this, so you should have this part of Lab 12 easy to download and install the package or module with all the Python code. And then it's just executing this statement to download all that text. And now I've got a big honking string, and I want to split the string and figure out how many of these particular patterns I've got in that text file. So that was what I wanted to talk about with Lab 12, is to let you know this is what's going on, this is why, how, and when. As I said, it's to give you some practice with an interesting new topic that's not a main line in the course. Now, you're doing some of this anyway, so you shouldn't have any problems, but let us know. With that, I'm going to get to the lecture, and I'll save the Project 3 stuff to the end. Okay. Wednesday, we're going to talk more about graphics and some of the things you're doing in Project 3. Tonight, I wanted to talk about comma-separated files. Okay. A .csv file is lines of text with each line separated by a new line character. The \n is a new line in Python. And on each line, each item is separated by a comma. Yeah, I left it in my note to myself. So here we are in PyCharm down here. Let's look at a file called data.csv. Oops, where am I? I'm in the wrong directory. There we go. So here, what we have, I ran this, it just has a simple thing. It's a line of data with each item separated by a comma. Okay. If you want to see something bigger, let's look at our Project 3 data.csv file. Okay. And what you see there is a value, then a comma, then a value, then a comma, then a value, then a comma, and so on. The new line is right here. This is a line of data. My screen is not wide enough to show the entire thing, but this is a line of data in a CSV file. One of the nice things about CSV files, comma-separated value files, is that there are a lot of applications that can produce them and can read them natively. So once you know how to deal with CSV files on your own, you can start using some of these commercial applications to help out your processing. And conversely, you can use your Python programming skills to improve the power of your commercial applications. Now, this is a Mac, as I've said, so I'm going to use Google Sheets. I could pull up numbers, but not enough people are familiar with Apple's numbers, so we'll let that go. Excel works the same way. If I was on my Windows box, I could use Excel and do the same thing. But we'll use Google Sheets. And all I've got is opened to a new spreadsheet in Google Sheets. It's blank. Let me open it. Okay. I want to find the file I just showed, which is, upload. Okay. It happens to be in my home, PyCharm projects, fall 2020, project 3 data. It's a big honking file. There we go. And notice that this file automatically got read in, properly displayed and packaged by Google Sheets. That's the advantage of a CSV, a comma-separated value file. It can be handled natively by Google Sheets, by Excel, by Numbers, by a bunch of other stuff. So that's why we wanted to know how to use them. Now, in Project 3, I gave you a shortcut. And that is, I let you use the Pandas package, which has built-in modules or built-in code for reading CSV. In addition to Pandas, there's an entire Python module you can get from PyPy called CSV. You can just do an import CSV, and it brings in all the things you need to read or write this type of file. But suppose I was a hard case and said you couldn't do that. Suppose I told you you had to use CSV files on your own. It turns out that you actually can. It's fairly easy to do. So this is the full path name of where that project is, where that file is, where my project 3 data is on my Mac. There's an example on the slide, which we'll get to in a minute, where for those of you who use Windows, I gave an open file with a Windows syntax. We'll talk about that in a minute. This is Mac syntax. If you were using Linux, it would be slightly different. But this is just the full path name for where on the computer this data file is. Now, that file has 3,422 lines. Okay, I don't want to read the whole thing in. So I'm going to open it as F. And now I'm just going to read in the first 10 lines into a list. So I'll start with a new list. For I in range 10. Data dot append F dot read line. Okay. And that should give me a 10 element that should give me a 10 element two-dimensional list with the first 10 lines of data from this CSV file. And there you can see, here is the first line. Now, notice one difference already. If you've gotten this far with Project 3, the header line. The data file, as we've seen, if we go back to the Google Sheet, the first line of the data file is a header row that tells you what the columns mean. It tells you the first column is year, the second column is state, the third column is the state's 2-letter post office address, and so on. Letting you use Pandas meant that you did not have to do anything about that header line, that the Python code, Pandas, took care of that for you automatically. You were set. Here, when I'm telling you, you have to read the CSV natively, you have to use only your own two hands and magic Python skills you picked up in this course. Now you have a header row. Fortunately for you, when we talked about 2D lists a while back, we talked about how to get rid of a header row. If we have a row that we just want to read in and get rid of, we use some trick called useless line or something similar equals F dot read line. What this does is this reads in the header row and gets rid of it. Okay. So now we'll actually, because we're reading in 10 and we've read in the one already, okay, what this is going to do is read in an extra line of code. But for now, we're okay with that because we're just limiting it to limit the amount of code we have to, limit the amount of data we're trying to display on the screen. Okay, and now we see the header line is gone. And in fact, the first bit of data we get is this string. Okay, so now by using read line in a loop, we've got 10 rows. We've now got a 2D list. So this is the first thing you can do to read in from a CSV file. Now, note that I did read line. Had I read the entire file with read, I would have to split on new lines. Since I used read line, Python has already done the splitting for me. Okay, I do have the new line read in as the last character of each line. So the new line was read in, Python read line consumed the \n, but it just kept it as the last element, and I can deal with it later on. So now, unlike pandas, where it read everything in for me and consumed the column headings and handled the first line and everything was great, here I had to do it manually. Now, what I'm going to do, remember, data is a 2D array, 2D list. Each row contains items. Well, now, remember, each row right now is a string. So I want to split up this string that consists of the first row. So if I just say print data sub 0, I get the entire string. If I say print data sub 0 sub 0, okay, it gives me just the 1 because it thinks this is all a string, right? It thinks this is all a string, so when I say sub 0, it means just the first character in this string, which is why it printed a 1. So now what I'm going to have to do is I'm going to have to split all of this on a comma. Well, fortunately, again, if I've got a long string and I want to split it up and get rid of some character like a comma that separates elements, I know how to do that. It's real easy. Okay, I'll say R for row equals, okay, I need to do this in a loop, but I'll say for I in range length of data. So that makes sure I take care of all the rows. I'll say I need a new list. I'm going to need a new 2D list. I'll initialize it here. R for row is a new 2D list. For I range length data, R dot append data sub I need to do this. I can't do this all in once. I'm going to get an error if I do this. So I'm going to say temp row equals data sub I dot split comma and R dot append temp. And I'm doing that because I believe that if I tried to combine these two into a single statement, I would get an error message. Okay, so let's come into this and see if we can make it work. Probably going to get an indentation error. Okay, that figures. Let's fix this here. All right. So now, what is R sub 0? R sub 0 is a list of this string is the first element. This string is the second element. Now R sub 0 is 1976, okay? Think about where I went up here when I said data sub 0, and I just got the 1 because Python thought that this was a single string, and so I just wanted the first character, index 0 of my string, so I only got the 1. Now down here, I have split the string, and so I now have a full 2D list. And so when I print the first element, the row 0, column 0 element of my list, I now have 1976. So I now have created a 2D list that I can work with from my CSV file. And I could go on and do that. Now, of course, further in, and I'll talk about Project 3, as I said, at the end of the lecture, to cover some issues that have been giving people trouble. We then have to work with these items. Okay, so let's go back to the slides. That's reading. Reading, as I said in Project 3, let's use some custom written code, specifically pandas, to read the CSV file. Now you have to do it the hard way. Step 1, you can use read line or read lines to read in the file a line at a time, since you know they're separated by \n, so you let Python do the separating for you. You certainly can read in a CSV file all at once using read. If you do that, you're going to have to split the rows on the new lines first. Okay, by using read line in a loop or read lines, you save that step. Step 2, so this is what I did when I put in the loop that did the read line 10 times. Now, step 2, I use split on a comma to split each line into its component elements. Each line is read in as a string, split that string on the commas, which, as you know, throws away the commas and separates the actual elements into their proper place. Step 3, all components are still strings. You still have to convert into ints, floats, etc. as necessary. So that's what we did here. Step 1, we used read line. We got rid of our header because we had to. We didn't get that free anymore. We used a loop and read line to read in 10 lines. I could have skipped the loop and used read lines. That's fine. Either one will work. This print statement was just to demonstrate what we had done. So this is all step 1 on that slide. Step 2 on the slide is this right here. This is splitting the data, splitting each row in the data on those commas. And as you remember how the split command works, the split breaks up the string every time it sees a comma. It throws the commas away, and now you have columns in your row. You append them, and now you've got a 2D list. And so now you've read in the CSV file, and now you can use it just like any other 2D list. So that's what step 3 says, is now that we've split everything, it's still a string. You're still going to have to do individual conversions to ints, floats, whatever, as necessary. So that is how you read in a CSV file. You can, and I'm serious about this, you can take a file that Google Sheets or Excel or Numbers creates, and in Google Sheets, I would come down here and I would say, let's see, is it download? Yeah, under Google Sheets, under File, Download, I would come over here and I would say, give me a comma-separated value. Give me a CSV version of my spreadsheet. So if somebody gives you a Microsoft Excel spreadsheet, you can just tell the system, you can tell Excel, you can tell Google Sheets, you can tell numbers, save me a CSV. Now that I have a CSV with this code that we've just talked about, you know fully how to read in and process CSV files in Python, and now you can do the work you want. So it's kind of a cool thing to be able to do. And as I said, I'm forcing you to do it the hardest possible way here, not using anything other than the tools you've got. There is the module CSV, there is the module pandas, there are other things that make it simpler, but in the worst possible case where you had no tools and no internet access to Google it, you could still do it. Now, writing to a CSV file is a little bit more complicated, but really not much. Remember, when you write to a CSV file, that you can only write one string to a file at a time. You can only write strings, and you can only write one string at a time to a file. So before we can write to the file to make it work right, we have to put everything together into a string. Now, lucky us, this semester, as Python programmers, we have learned how to put everything together into a string. Specifically, it's the join command. The join command takes a list of inputs and combines them into a single string so that you can now write that single string out to the file. And that's creating a CSV file. So creating a comma separated value file, a CSV, we're going to use a comma in the join. So the specific command we're going to use is we're going to say comma dot join parentheses, and that will automatically put the commas into place for us. So using the join, using a comma join, puts the commas into place between the components of the string, and thus gives us comma separated values in our output, which is exactly what we want. But you do have to remember how join works, okay? Join only works on iterables, lists, or dictionaries, so what comes in here in these parentheses is going to have to be either a list or a dictionary, and those components themselves have to be strings. So here is an example which we will go to PyCharm for. The simplest case, let me come down here to a thing. We're going to say S equals the string 1, the string 2, the string 3, the string 4, the string 5, and the string 6. Now, if I want to take that list, S is a list of strings, right? Nothing magic here, no hocus pocus, nothing up my sleeve. S is a list of strings. If I want to take that list of strings and convert it into a single string so that I can write it to a data file, now I use the join command. So my new thing, my new result will say that L equals join with a comma. That's the syntax, S. This command says take S, which is a list, and build a single string to get out of it by joining it all together, separating each element with commas. Okay, so what does L look like? It looks like the single string 1, 2, 3, 4, 5, 6. Okay, up here, originally I had a list of 6 strings. S hasn't changed, by the way. So if I want to know what S is still a list of 6 strings. L, which is created by the join, is now the single string. The nice part about this is now I can write L out to a file, and I have a CSV file. I have a comma separated value. Okay. Now, the notion about things that are that can be used in join is, suppose I take another list and I'm going to create a list of the integers 1, 2, 3, 4, 5, 6. These are not integers. These are not strings. These are integers. And I say, n is equal to comma dot join r. I get an error message. Okay. And the reason I get the error message is because you can't join. It says it expected a string and it found integers. You cannot join lists of integers into a string using the join command. It doesn't work. That's what this slide means. So what this slide tells you is the basic idea of writing to a CSV file. Says if I have a list of strings, I can use the join command to combine them into a single string, and then I can write that to my file. But if instead I had a list of integers, that wouldn't work. If I had a list of integers, if this is what I actually wanted to write to the file, I would have to convert each of these integers into a string first. What does this produce? You've just seen what that produced. It produces an error because you can't join integers in a string using the join command. Okay, so this is the basic idea. To write to a CSV file, we're going to have to use the join command to build strings separated by commas, and now we can write those strings to a file. Okay, now we haven't covered writing to files a lot. You did some of it in this semester. Write is a single string to a file. You write one line at a time. Write lines lets you write multiple strings to a file in a single statement. So if you had a whole list of strings, you might want to use write lines. In our example, we're going to use write for simplicity. We're using write because it writes a single line, a single string, a single line to a file. Yes, write lines does exist. We're really not going to go into it for simplicity. We'll be using write. Okay. So now our code looks like this, and I'll cut to PyCharm in a minute, but I want to get to this code. I told you when I showed you the path name to the file on my Mac, I would show you a path name on Windows. This is what it looks like. On my Windows box, I had the data file in my hard drive, C, my list of users, Al, which is me, PyCharm projects. I actually put it in my exam questions document or directory, data.csv. So the file data.csv on my Windows box was in C: users, Al, PyCharm projects, exam questions, and then data.csv. Now, remember, Windows is different from Mac and Linux because the slashes go the other way. The slashes are backslashes. They go from top left to bottom right on Windows. In Python, the backslash is an escape character. New line is \n, tab is \t, and so on and so on. We covered that earlier this semester. So if I just said the path name was C: \users, \al, \PyCharm projects, etc., PyCharm, any Python interpreter, will barf on Windows. It will not accept that. So when you're using Windows, you have to escape your backslashes in your path name. So anytime you're using a full path name in Windows and Python, you have to use these double backslashes because Python has overloaded the definition. Python already has a use for the slash. If you put a single backslash here in Windows, it'll fail. The double backslash just escapes it. So this tells Python, when I say this is the full path on a Windows machine, this tells Python it's on my hard drive, C, users, Al, PyCharm projects, exam questions, data.csv. And that is the file in which I'm going to write to. And the variable name I'm going to call it is outFile. I'm going to call it outFile in my program. This is where it is. Now, let's go back to PyCharm. I don't lecture from my Windows box. I lecture from my Mac. So all I've done here, the only difference between this code and the code on the slide is this is what the path looks like on a Mac. Okay. And so when I say the slashes are different, this is a slash to separate directories in a path on a Mac. On Windows, it goes the other direction. It's the backslash. Only difference there. Basically, what I'm doing is what I just did. I create this list L, I call it here in this program. L is a list of strings. Remember, it has to be a list of strings or the join command will not work. So I have a list of strings. Okay. I join that list of strings into a single string using the join command. I join L, and in between every element of L, I put a comma. Okay. And this just is a print statement to show you that it works. Now, what I'm going to do is write it to a file. Okay. I'm going to show you here, make sure I'm in the right place. There is a file called data.csv. I'm going to get rid of it. There it is. Okay, there is a file called data.csv because I was running this already. So I'm going to delete it. And as you all know, Bash programming, Z shell programming, all the same, Linux, you get rid of a file by RM. RM is short for remove. Remove data.csv, it's gone. There is no data.csv file here anymore. Okay. I could show you everything. There is no data.csv file in this directory because we deleted it. So now when I run this program, what I'm going to do is I'm going to deliberately write the string twice. Why? Because I want two separate lines. Why? Because I'm going to illustrate something in a minute. Okay. So let's copy that into a console and let's execute it. This is just the result of my print statement. I kept it there to show that the code was working and I got the right thing. This is a string. Now let's go back to our terminal window. Let's remember there was no data.csv. Let's go and see that there is a data.csv and what's its contents. Okay, there is my new data.csv 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. You know what? I'm going to change this a little bit. I'm going to go back and I'm going to put another new line at the end of that second. And that's a syntax error that has to be fixed. What I'm doing is I'm going to put a second new line, write a new line, just so this looks a little better when I look at it. Write, the write statement in Python does not write a new line. It just ends where it ends, right at the end of your data. And so I have to specifically write these new lines to make it go on another line. So now what I've done is I've added this. Let me go back into my Python console. Let me run my code again. Let me go into my terminal again. Let me cat data.csv again, and it just makes it a little easier to understand. Okay. This is all I did was I put a second new line so that you didn't get the prompt on the same line as this. It was easier to see. Now, here's the magic. Data.csv is a file we created. It's a file we created with a Python program, right? You all saw me, nothing magical. I just created a file called data.csv by creating strings and printing them out. Let's go back to Google Sheets. Let's do File, Open. On a Mac, Google Sheets, I'm going to upload. I'm going to search for it. It just so happens that since I uploaded the last file from this directory, the Mac and Google Sheets starts right there. So here's my file data.csv. I'm gonna load it into Google Sheets. And when it loads, I have a brand new Google Sheet. And the point I'm trying to make is this. Okay, if you look, okay. If you look, make it a little bigger, make it a little easier to see. Okay. Because it's a CSV file and Google Sheets knows how to handle CSV files, it automatically read in my data. You saw the data in pie chart. I can still show it to you today. It's 1, 2, 3, 4, 5, 6. Google Sheets said, aha, this is the first element, the first column. This is the second element, the second column. This is the third element in the third column, the fourth, the fifth, and the sixth. And then Google Sheets saw the \n for the new line because I wrote a new line. And so Google Sheets said, that is your next row, right? Here's the first element, the second element, the third element, the fourth element, the fifth element, the sixth element. The point of all this is simply this, that by using this simple Python coding, let me go back to a normal size. By using the simple Python coding technique that we just learned, that we've been doing this semester, we can create files using Python that can be automatically read in and processed by Google Sheets, by Excel, by Numbers, by many, many similar programs. Okay. So what you've learned in this computer science class is the skills to do the coding that can then enhance the capabilities of the tools you've already got. So that was really the purpose of this part, is to show you that you can take data and you can create things, you can create files, data structures that can then be consumed by other people's software. The people who wrote Excel have written it just to load your code in and use your results natively, accurately, just the way you meant them. Okay, and they will do it. And it works fine. Now, we always get one question, so I threw a slide. What happens if we have a CSV file, but some of the data has comments in it, commas in it? Let's try this again. What if I don't want, in some particular case, a comma read as a separator of components? I want a comma to be included in the data. In other words, you have a field name. You don't have separate fields for last name, first name, middle initial. You have a single field called name, which is Arsenault, comma, Alfred, period, Alfred, comma, W, period. Okay. Commas are part of the data, and commas need to stay in there. What do you do in that situation? Well, it turns out that in practice, if this was an issue for you, here's the cheat code. You would import CSV. CSV is the Python module that handles all of these issues like this, like commas in the data. And if you go to your Anaconda Navigator and look in your environments and search for, now watch it prove me wrong, but search for CSV, you see that it has modules for handling CSV right there. You won't have to go to PyPy and use pip to install it. Okay, you've got it included, but you can, there are other variants, you can get them from other places as well. Okay, so in practice, if you had to do this in real life with your coding, you would use one of those pre-written, pre-packaged CSV routines, and it would handle it for you. But if you didn't have it available, you forgot that was available, and you just wanted to show off your massive coding skills with your programming, with your Python programming, the short answer is embed the comma in the string before you do the join. Okay? Before you do the join, embed the comma in a string, put quotes around it, use something like quotes around the string so that the comma will later be skipped. Okay? If that's your problem, if that's what you want to write data that has commas in it, then that's fine. Now, if you're reading the file, you might not be able to do that. If somebody else has created a CSV file for you to read, and they have not had the foresight to shield the commas by putting them in the middle of quotes, in the middle of quoted strings, then there's no explicit way to do this. You're just going to have to do some EDA, exploratory data analysis. You're going to have to look at the data file ahead of time and see what you're dealing with and see if you're going to have that problem. And then on a case-by-case basis, you're going to have to address it. Now, one of the ways to do that is if we go back and look at Google Sheets, and we go to download again, we see there is another form, which might be useful, .tsv. TSV is tab separated values. And in that case, what you have is each individual item is separated by a tab character, the \T in Python. Okay. And so if you have a tab separated value, then a comma is just a comma, right? Sometimes a comma is just a comma. It's not a separator. And tab separated values is a good way to do that. So if that was what you were trying to do, if you had a case where you really had a lot of commas in the data and those commas were just commas, they were not particular separators or anything else, then what you might want to consider instead is using a tab separated value. In a tab separated value, it's really trivial. All you do is in this join statement, tab separated values, you say S equals, remember that the tab is \T, there's that escape character again, .join L. Works exactly the same way. And if you do that, you now have a tab separated value file. You would probably call it .tsv, not .csv, because if you called it the wrong thing, then some programs would figure out it's tab separated, but other programs would choke on it and you'd have a problem. Okay. So that is reading from and writing to .csv files. When I'm harsh and tell you you can't use any tools, you can't use any packages, you can't use any pre-existing Python code, you have to do it yourself. As you see, doing it by yourself is not hard. It's a little annoying. You have to write a little extra code. You have to take a couple of steps extra to deal with that header line that's done automatically for you. You may have to do something with the \n, because when I showed you in PyCharm the code that we used when we read this file in, okay, the \n's are still there. What did I call this? Let's go back to the read-in code. I called it R. Oh, wait a minute. What did I do? Oh, I reused R is what I did. Hang on. I apparently reused R somewhere in here, but at any rate, let's do this real quick to get back to the case I was trying to make. Okay, there we go. Okay. That fixes it. Don't know how I reused it, but okay, fine. You notice in each row, I still have that \n. I still have that new line. I have to get rid of it. Not a big deal. You know how to get rid of characters from a string now. It's just subscript, substring, index them, take slices, etc. And then, of course, I probably want to change the number of votes from a string to an integer and so on. But the bottom line is you can do this. And when you do this with your Python programming, you can create files that can be read in and used in native format by applications. So that is what I wanted to cover about CSVs and a quick mention at the end of TSVs. So right now I've got 15 minutes left. If you're confident with where you are in Project 3 and don't think you need to listen to me for anything, feel free to leave. I'm going to spend about 15 minutes, the last however long, talking about Project 3. Let me see if I can get a Jupyter notebook running. Here we go. All righty. Let me get a new Python 3 and hope this works. Okay. Import pandas as PD. Import plot9. Let's make sure those run. Okay, it looks like they did. Read in the data file, PD. I imported pandas as PD, so I don't have to type pandas. I can just type PD. .read underscore CSV. The full path on this computer on my Mac. If you're using Windows, it might be different, but on the full path on Mac looks like this: users, Alfred Arsenal, PyCharm projects, fall 2020 project, project 3 data.csv. And remember that I told you might have to use an encoding equal ISO 8859-1. Okay. Let's run that and deal with any errors we get. Okay. Now, pandas has a nice command that I don't have to read the whole, I don't have to print out the whole file. I can just use head, and head prints out the first and last few items, the first 5 and the last 5 by default. And now I can see that indeed I have read in this file correctly. Okay. Now remember, this is not a 2D list. This is a pandas data frame. We can't use the pandas data frame directly. We need to convert it to a 2D list. And I told you in the instructions how to do that. Let's call our new variable df equals data frame dot values dot to list. Okay, and run that cell. And now let's print, let's say, for I in range 5, print df sub I. Okay, and let's run that cell. And now we can see that we actually have a 2D list, and I just printed out the first 5 rows of it. Okay, notice that pandas, because I allowed you to use pandas read CSV, the header row is gone. I didn't have to worry about the header row. It was taken care of for me. And more importantly, all the things that are supposed to be integers are integers and booleans and things like that, and floats even. Pandas has already done that conversion for me. When I talked about doing CSV by yourself the old-fashioned hard way a few minutes ago, I told you now, step 3, which I didn't bother showing you, is now you have to go through and convert integers to integers and so on. Okay. I let you use the pandas read CSV because it does it for you and you skip a step, and that's not any, great programming skill. Anyway, so now you're fine. Well, now I'm going to skip the sorting routines because I gave you a quick sort, I gave you selection sort, and I told you just, take the routines, modify them a little bit, but run them and compare the results. Warning, you can use quick sort is recursive. Selection sort, you can use either the iterative version or the recursive version. I don't think I told you in the assignment which one you had to use. If you use the recursive version of selection sort, you will exceed, in all likelihood, the max number of recursions. We talked about this briefly when we talked about recursion. Every Python implementation has a max number of recursions it will allow you to run. The default is typically 1,000. Okay. If you run more than 1,000 levels of recursion, Python presumes you done messed up. You're in an infinite loop and it stops you. So if you are running selection sort recursively and you run out of recursions, then what you do is you just set your max number to higher, because there's 3,421, I believe, rows of data, and selection sort doing recursively will need all 3,421, which is greater than 1,000, so you'll get the error message that you don't want. But that's how to fix it. Here is what I wanted to get to. I want you to go through all of this junk, all of this 3,421. And I don't mean to be disrespectful. I am a great believer in politics, in American politics and democracy. And everybody from any party who wants to run should run and be respected and have their results reported. However, when we're talking about analyzing election results, the reality is the people who win elections, with a couple of exceptions, are Republicans or Democrats. And I told you who the exceptions are. And there's actually one more exception I missed, which is a really weird case. I'll tell you that one in a minute. You don't have to worry about it in your program. Okay. So I want you to pick this candidate, and I want you to pick this candidate, and I don't want you to pick anybody else. Okay. Except for the ones given you. Furthermore, I only want you to deal with certain columns. I want you to deal with the year column. I want you to deal with the state code. We're not going to use the full state name. We'll use the state code. That'll make analysis and graphics a little easier. And I want you to talk about the name. I want you to talk about the party. And I want you to talk about the number of votes the person got. Now, so what we're going to do is we're going to create a much simpler 2D list. What I want you to do is take this big, ginormous, big honking 2D list that you already got, and I want you to create a simpler 2D list. Okay. To simplify this, I'm going to define some constants that are column numbers. So I'm going to define a constant, year. Year is in column 0. I'm going to define a constant called state. State is in column 2. Column 2 because we're using the two-letter abbreviation. We're not using the whole state name, which is in column 1. I care about the candidate name. I don't want to necessarily use name, so I'm going to say candidate. Candidate is in column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which actually works. So candidate is column 10. Party is column 11. And votes is column 14. And those are all in the instructions. Okay. And now, so that's fairly easy. That's just showing you how to create, how do you make constants to make things easier. Here's what we're going to do. We need to decide who we want, right? Republicans, Democrats, what have you. Okay. Step 11 at all. What is step 11? Hang on a second. Oh, the graphics, not yet. We'll talk about it on Wednesday. I want to make sure people get there. Good question, though. But yeah, we'll talk about the graphics more on Wednesday. Okay. Here is the simple part of it. Okay. I'm going to say for I in range length of DF, I'm going to go row by row. And that just gets me through row by row in my file or in my 2D list. If DF sub I sub party equals Republican, then I know I need this. Now what I'm going to do is, how to add a new row to a 2D list. We talked earlier about how to add a new row to a 2D list, right? We're going to append it, but in order to append it, we're going to have to create that row item by item. So I'm going to call, the new 2D list, which I'm just going to call new 2D list, is a blank list. Okay, if this is a Republican, then I want this person, I want this row. I'm going to define a list L, which is all the values I need. Year, state, candidate, party, votes. In other words, this is the list 0, 2, 10, 11, 14. Okay. So I'm going to create a new list for J in L. For J in L, L is year, state, candidate, party, votes. Okay. Or L is 0, 2, 10, 11, 14. So the reason for J and L is this gets me only the columns from the original row that I care about. So what this is going to do is going to say temp.append parentheses df sub I sub j. What's happening here in this loop? I am building a 1D list. The way I am building that 1D list is I started with an empty list and I added elements to it one at a time. Which elements did I add? I added the ones that were told here. This says go to this row. Remember, we're dealing with a row in the original 2D list. What I'm doing is I'm saying take the year, then take the state, append it, take the candidate, append it, take the party, append it, take the votes, append it. When I have done this, now I have a full row. I have a full row that contains everything about this candidate that I care about and nothing else. So when this is done, okay, when this is done, then I can append that new row and I'm done. So what this does is this is the code that builds the new 2D list that contains only the data that I care about. Okay, so this is step 10 that we just talked about. This is going through the original data file, going through the original list, and creating a new row by appending only those elements I care about, and then appending that new row. And when this is done, I have the new 2D list. That's all I care about. Now, I've only showed you Republican. I haven't shown you Democrat. I haven't shown you Bernie Sanders. I haven't shown you Angus King. I'm not going to. I mean, you have to do this coding yourself. It's really not that hard if you understand what I'm doing. Now, I understand a couple of students have built this new 2D list separately, a different way. That's fine, providing it works and you document it properly. That's all well and good. I'm fine with that. Okay, so the bottom line on that is that this is a start as to how you would build that 2D list. Okay, that new 2D list is called for in step 10. When you write all of this stuff, when you get all of this stuff done completely and tested, then you will have everything. And since I'm out of time, the one thing you do not have to worry about it, I hope I don't confuse you, but I realized looking at the data, there was one other one I missed. Lisa Murkowski from Alaska. There was one election in which Lisa Murkowski, who is a Republican, lost the Republican Party primary. She was defeated in the Republican primary. And so she chose to run in the general election for the Senate in Alaska as an independent, as a write-in, and she won. So there is one record in there in which there would actually be another independent senator who won, but I'm not going to worry about it. We're not going to count it because she was really a Republican anyway, so we're just not going to include that data point. That's the bottom line. Okay, is you build this 2D list. This new 2D list is only people we care about are Republicans, Democrats, Bernie Sanders, and Angus King. And that gets rid of most of our 3,421 data points because we don't, apologies, don't mean to sound disrespectful to the independents and the libertarians, but we're not including them in their analysis because they don't impact the results. With that, I will let you go. We're past time. We will lecture on Wednesday is going to be on graphics. That's our special topics lecture, and I'd be willing to do some discussion of the graphics parts of the project on Wednesday. And of course, I'm available. Ping me on Discord or whatever if you have questions. But other than that, thank you very much. Apologize for keeping you a little bit longer, but we are done. Thank you.
Hi, Professor.
Yes.
Hi, so